All right, good morning, everybody. So what I'm going to do today to start out is I'm going to go over what today's Lab Wednesday assignment is. And as I walk through it, I'm also going to review the insertion process for a singly linked list. Because what you're going to do is you're going to use inheritance and polymorphism to build a sorted singly linked list. So I have the description here on the course page for Lab 11, and I've provided you all the code. This gives you the opportunity to, perform wget to get the information. You'll have all of the singly linked list code, and what you're going to do is you're going to fill in what is in essence a blank file. So let me bring this up here. And, oh, 404 not found, what? Oh, this should be Lab 11. I'll make that edit. Yeah, so basically I have a if not defined, defined, how to include sort of singly linked list and end if. So I will describe it while simultaneously making the edit, these two edits that I need to make on it. So what you're going to do is you're going to download all the singly linked list code. And then what you're going to do is you are going to define the class in the singly linked, sorted singly linked list, and you're going to use the techniques that we first learned with dog class, inheritance and shape, right? So you did the shape class and you did the rectangles and squares, but now you're going to start adding in templates. So you have to review what I have in the slides about how it is that you construct a derived class using templates. So you're going to do that in this sorted SLList.h class. And I have all the rule reminders included again. And so I've included hints here at certain rules. So rule 4 here, I say if the class is templated, then template the class definition. Also review in the slides how to do a public base when the derived class is templated. So that's a hint there to let you know that if you don't understand it, it's in the slides, and that slides 10 to 19 in that lecture, and that'll help you identify precisely where it is you need to look up. So for those of you who were on the page before, please refresh so that way the Lab 11 links are correct here. And so also review how to call derived versus class members in slides 23 through 25. This will be necessary to do the insert method. So you are going to write an insert method in this sorted singly linked class. So after you've constructed it, you're not going to need to have any private members because the private members for the sorted singly linked list nodes are already provided for you. So you're inheriting that. So it makes the process simpler. The crucial thing is you're going to have to identify which methods in the base class need to be virtual. And then from there, you need to figure out how it is you're going to actually sort once you insert. So you have to do insert, and then you also have to write a new friend operator to print out the results. So first here, I write the definition of the sorted singly linked list class. The default constructor should call the singly linked list constructor, and I've described how to do that in slides. And then next, the focus is to study the insert method and then construct a similar method with a sorted singly linked list. And I've given the 3 cases that we accounted for in the actual insertion method in the singly linked list class. So what I would like to do is I would like to bring that back up and go over those again. And what I'm going to do is I'm going to ask you what you think might be different if you're trying to put them in a sorted order as opposed to just putting it in the back. So first, we have the first case only where the class is empty. So let me walk through this again just for review. And what I'm going to do is we create a temporary node. And remember, it has a data point and it also has a node pointer to the next location. And then I check this is empty method. And if it is empty, we just set the head node to the temp. So my question to you is, if we're doing a sorted singly linked list, is there anything we need to do differently for this case? So if I want to sort everything and I'm putting it into an initially empty list, would this change anything sorted versus unsorted? Check the chat. We got everybody seems a little quiet today. Now let me rephrase. I think there's a lot of there might be some engineering overthinking going on. So if I have nothing, right? I'm sorting a bunch of numbers, and currently I have no numbers, and then I put in 11. It's the same, right? Yeah, if some light bulbs went off there. So that's the same thing. So at the beginning, when you're writing up your version of insert, you're going to do the same process for inserting at the head. Like, all right, I'm inserting the first one, it's going to be automatically sorted. So here we have the else case. And this else case, we have to think about if we're putting it at the front, if we're putting it at the end, and if we're putting it in the middle. So right now we only have one element. So if I have an element, let's call it 11, let's say that the data is equal to 11. And I want to call 10. I want to create a node 10. The code that is currently in the singly linked list, what it's going to do is it's going to iterate through doing that walking technique that I showed you last lecture, and it's going to put it at the end, right? So it'll create a new temp node here. Next is going to point to null, and then we update this pointer to point here, correct? So if I want 10 to be in front, what do you think I might want to do differently? So let me walk through these steps where I'm putting it at the end, regardless of what the value is. So what happens is I create a new node. I check if it's empty. It's not empty. I create a previous and a cur. And then I just keep going until cur is null. So I want to go all the way to the end in an unsorted list. So I'm set previous and I set current. And then I would just update the nodes, right? So what do you think we would want to do differently here? I said clear all drawings, there you go. So what do you think we would need to do differently? What would be the case? So previously we stopped at current is equal to null, correct? So where are all the cases that we would want to stop if we're trying to sort it? Yes. Correct. So we're checking for two different things. All right. So right now what you're saying is we have this line of code is where we need to modify, and we should have a case where if cur, and how do I get the value in there? Cur arrow what? What's the keyword I should use? So head is the pointing to the head node. If I want to compare the value I'm passing here, what I heard it. So can someone say it again? Got it, right, very good. If cur, while cur data, so I want to continue. We're going to keep going until I find an appropriate location, right? So while cur data is less than value. And the reason we say less than is because I want to find a place where I want to stop. So the second question I have for you is, what is the other scenario we need to consider? So we've already considered data. And what would be the other thing we'd want to consider? Yeah, what's that? We have to consider an address, so you're on the right track. A specific thing will return with an address, though. Yeah, go ahead. We have to consider next. So when do we want to terminate? If I let's say I have the largest value that would be in the singly linked list. 10, 11, 13, and I'm inserting 22. So we're checking 22 is not 22, the current data is less than 22, so 10, 13, and 22, yes. Very good. So while we still want to do cur is not equal to null, and cur data is less than value. So those are the two choices. And here is why. If the value at the head node is less than the value, right? So we're going to have previous and cur. So previous is going to point to the initial value if it's not empty, right? And then we're going to have cur pointing to the next location. So we should say, well, cur is not equal to data, and I think I've actually should correct myself, while previous data does not equal value. So here's how this will work. So here in this case, let's say I have 11, and here previous is pointing to null and cur is pointing to head. So it's going to be cur null, oh, yeah, it is cur. So cur data would say, well, 10 is the value and 11 is cur arrow data, right? So we have a scenario in which it's less than. And so what we would do is we would want, and let me go a step back because I think that might provide clarity on. All right, so this is where we would be, right, initially. So we would create a node, and current, this would have 10, and this would have 11, right? So I want 10 to be put in the middle. So in this case, we have to account for the scenario in which head needs to point here, and 11, I'm sorry, and then 10's node needs to point here, right? And so now that singly linked list is in order because that allows us to be able to say, all right, if it's less than the head node, we just push from. Then, otherwise, if I have another scenario, and let me bring up a whiteboard here. There we go. When we have a scenario, so let's say I have 10, 13, and 15, and I'm trying to insert 14. So what's going to happen is the head node is going to be currently pointing to 10. 10's next pointer is going to point to 13. 13's next pointer is going to point to 15. And 15's next pointer is going to point to null. Does everybody see that? So now I want to insert 14. Let me make that blue so it's clear. So 14, I would be creating a node here, right? So what would happen is cur would be pointing at 15. So we would be going while cur data is less than the value we're getting in. So now 15, we have cur data. That's now going to be greater than value, which is 14. So now we have this other scenario, and this is why we should keep track of previous. So this is going to be cur. And this is going to be previous. So does everybody see the benefit now of why we want to keep track of a current previous node? Because we can't go backwards on a singly linked list, and therefore we have to have some way of knowing where the previous value is. So how do you think, and so this would be temp. So how do you think I would want to actually insert 14 into this list? What are some of the steps you think we need to do here? Yes. Very good. So we're going to say previous next is equal to temp. So so previous next is equal to temp. Very good. And then what's the next thing you think we need to do? Yes. Very good. Absolutely right. And then when we go out of scope, what's going to happen is these pointers will all go away. And then that value will be in there. So the ways you can account for this, you first check if it's empty, you just insert. If the value is less than the head node, then just call that push front method. Otherwise, you would either iterate until you have two cases. Either this case that we just encountered, where we're inserting between two values, or when cur is equal to null, in which case you would just do the normal insertion that we've done before. So what you're going to do is you're going to, in this lab, demonstrate that you can create a class with a templated type that is inherited from the base class. The base class is the singly linked list, and all you need to do is create the insert method. You are inheriting the isEmpty method. You are inheriting the push front method. You're inheriting delete. So when you delete from this singly linked list at the end, like I'm going to demonstrate in the run, it's fine because it's just going to delete the exact same way. At this point, it doesn't matter what the order is. If I want to delete 14, we're just going to do the same thing where we set this here, so that gets erased first, and then we would free temp. So now fit 14 would be out of the linked list. So if you're able to follow those steps, you will be able to complete the sorted linked list. And so let me show you a run of the result. At the end, what it's going to do is that you can prompt, you run lab 11, and then you're going to put in the values. So in the singly linked list run, and in the code that you've downloaded, when you've downloaded, this will print out without the sorted linked list in one file. So, and in fact, I'll even go into the folder where I have all this. So I have it in lab 11. Right? So these are the files that you are downloading. And if you run make lab 11, it will compile. And if you do lab 11, let's do 10, 15, 7, 19, 22, 8, and 44. So what it's going to do is it's going to call the overloaded operator to print all the values in the normal singly linked list. And then when I delete, let's say I delete 19, you can see that it's taking it out and maintaining the order. 10, I did 20. 20 is not in the list. Good, that's a good check. Let's do 15, 22, 7, delete the head node, delete the last node, delete the head node again. So that's what's going on. That's what you'll be able to download, and that's what you'll get. But notice how I'm also printing the sorted linked list. So at each step, when it inserts initially, you should also call, and it says this in there's a place I have commenting that tells you where you should do this. And you see how it's sorting? And it gets all the way through, and then I prompt and I'll say 15. So 15's here in the sorted linked list, 15's here in the normal linked list. And you'll see that it maintains the sorting, and I'm able to go all the way to the end. And at the end, it just prints them both as empty. So you need to create insert, you need to create an overloaded operator, and to get there, you'll first need to create an inherited class. Yes?
Can you explain like the conditions for insert one more time?
Okay, so you have to consider about whether the linked list is empty. You have to, and so I'll get in front of the screen so that way. So you have to consider when the linked list is empty. You have to consider when the value you're inserting is less than the data within the head node. Then you have to consider what will happen if you're inserting and you're not at the end of the linked list. And then you have to consider when you're at the end of the linked list, so when cur is equal to null. So those are the four main things you need to consider. Okay, are there any other questions? All right, for those of you who came in a tad late on the chat, I just want to point out that I refreshed the page, so it says lab 11 instead of lab 10 now, so just make sure you do that properly. Okay, does anybody have any other questions? All right, so I'll remain here until 10 o'clock to take any questions. I'll monitor the Slack. And this is, I'll make sure that this is reflected on the lecture notes page as well. This is still due on Sunday as normal. So you can get it done today, knock it all out, and then have a good intro to computing free weekend. Or you can modify that. But either way, enjoy your Friday off, relax a little bit, get a breather before we go into the final home stretch here. Okay? All right, let's do it.